So what we're going to do with logarithms is logarithms allow you to do this. We know that 2 squared is 4, and 2 cubed is 8. But what is 2 to what power is 6. That's what logarithms allow you to figure out. Okay. Logarithms allow you to solve for exponents. Logarithms deal within just what are called bases and what are called exponents. Logarithms have a ton of different properties, ton of different little rules and things like that. We're going to start out, and we graph them as well. When we graph E, if you guys recall, we only need 1 point, and then you just shift that 1 point, and you follow decay or growth. Logarithms, you're able to graph 2 points, and it's a little bit easier to work with. Probably not going to do the graphing today or tomorrow. I'll probably wait to do the graphing until next week. We'll work on properties today and just kind of build out of it. I think logs take us through 7.4, 7.5, and then I think 7.6 is when we start doing a lot of the equation stuff with it. And then 7.7 is some of the modeling functions and all that. So if you think to 8, sorry, it's 8, 8 to 8, 4, 8, 5, excuse me. If you think about some of the stuff we did yesterday with the principal and interest style problems, you know those problems that you guys were using your table to look for the value of t when something would occur? You could have used a logarithm to solve it for an exact value. You just didn't know that yet. Now you do. Now we can do that. It's exciting. It's log. Yeah. Whatever. So anyway, so here's what happens. Logs, this is kind of the important way, it's kind of the terminology of how we say it. We say it's a log base b of y equals x, and b to the x equals y. Those two statements are the same. Log base b of y equals x, b to the x equals y. What happens is that log bases can change. On your calculator, there's a button that says log.
I always wondered what that button meant.
And this is where it comes from. You use logarithms, and you've used them in chemistry, haven't you? Who's in chem? Anybody in chem yet?
No, we didn't use
Last year.
I think you had.
We didn't use it.
Okay. I think, because I know that you can.
I
Okay.
don't know if I was supposed to.
Well, it depends on what you wind up with your answers.
That's true.
So, but yeah, I know in chemistry you use logarithms because my wife says, why do we have to use logarithms? She teaches chemistry.
the reason why you signed the
Yeah, exactly. So what we do here is we say it log base b of y, or like log base 3 of 7 equals something, and so on and so forth. They're equivalent statements. What we're going to work on is rewriting back and forth, and some very easy simplifying via exponent rules over the course of the next day or so. So special logarithms. These are the important ones that always hold true. These are the two values that are going to allow us to graph eventually. Log of 1. So what happens is log base b of 1 equals 0, because anything raised to the 0 power is always 1. If you're looking at this, for the very first time, you're saying, what in the world does that mean? Which probably most of you guys are. It says log base b of 1 equals 0. In my head, I'm asking, what base to the 0 power equals 1? What base to the 0 power equals 1? Well, any base to the 0 power equals 1. So that b value can be any number. All right? Anything to the 0 power equals 1. That's what that means. All right? It's another way of rewriting an exponent rule. Same deal going the other direction, or the other way. Log base b of b is 1. Well, that means anything raised to the first power is itself. That's all that means. Anything raised to the first power is itself. So if it's log base 4 of 4, that has to equal 1. Right? That's what those things mean. We use these two rules to graph, and like I said, we'll probably spend, I don't know if we'll get to it tomorrow, we might not, it really depends on how fast we go, but we use these two properties basically for graphing and some very easy simplifying these on here as well. And like I said, these are what you call equivalent statements. Okay. Yeah. So let's spend some time talking about writing them from what's called logarithmic form to exponential form. We're going to write things from logarithmic to exponential. So logarithmic is your log base b of y equals x, and your exponential is b to the x equals y. That's what that means to rewrite between logarithmic and exponential. So if I have the log base 2 of 32 equaling 5, let me just go these one by a time. If I have log base 2 of 32 equals 5, that means what exponentially? Base is 2. So your base is 2, so it's 2 to what power is 32?
The fifth.
2 to the 5th is 32. That's what that means. So in the back of your mind, as you start to think about things, what would they be doing in terms of solving like an equation and whatnot? What you might see is something like this. Log base 2 of 32 equals what? That means 2 to what power is 32? Okay. Yes, you can do logarithms by hand. Yes, you might need a calculator for a logarithm. If it's ever going to be a logarithm by hand, it's going to be something you're going to be able to figure out. 2s, 3s, simple base 4, simple base 5s, nothing too crazy, getting too big too fast. Let's get another one. Log base 5 of 1 equals 0. Now, to rewrite that in terms of exponential form, that means what? Very good. 5 to the 0 equals 1. There's your exponential form. 5 to the 0 power is 1. What's that? Log base 10 of 10. Yes, ma'am?
Is there any particular reason that they have the answer to the that form, like on the left side of the equals sign? Like, does it matter which side of the equals sign?
It doesn't. You can have y equals b to the x if you want. It's fine. It doesn't matter. It's just the way that the book writes it. The pre-calc book writes it backward. They write it with a's and c's as opposed to b's and x's, which is weird. So, oops.
B. 10 to the first power. That's 20.
Yeah, 10 to the first power is 10. Does that make sense?
No indication of that.
Now, one of the things you will see from time to time, and I'm gonna put this up real quick, is if it just says log 10 equals 1. The logarithm base that you don't see, if you ever see just the word log, it implies that it always is a base 10. That means that there's a 10 here that you just don't see. If it's any other base, it'll be shown. It'll say log base 2, log base 3, or whatnot. If you don't see a base, it has to be base 10. Does that make sense?
Even if the thing that's showing is not
It's
10,
like
it's still.
log 5.
If it was log of 5, it's still log base 10.
Okay.
Okay. It still means the same thing. Does that make sense? This wouldn't equal 1 then, but this would still be, if it just says log 5, it means it's implied as a base 10. Just like, what's the coefficient there? 1. It's implied that it's a 1. Okay? That's all that means. Base 10 logarithm were the standard logs way back when, and that kind of held through. Nowadays, your calculator is able to change the base by pressing a couple of buttons, whereas back in the day, you had to do a little bit more calculation stuff. So they kept things as base 10 to make that work. All right, so back to this one. Log base 10 of 0.1 equals -1. Now, a lot of times you might see this written a little bit differently. You might see it written like this. Log base 10 of 1/10 is -1. Now start thinking about your exponent rules. That means 10 to the negative 1 is 1/10. Very good. Does that make sense how they interchange back and forth? Okay. This means 10 to the negative 1 is 1/10, or 0.1 if you want to write it like that. Depends on how they set it through. You will see when you have log bases of fractions, that means your answer had to have been a negative. You cannot have you will not have a negative log base. It's impossible, so you don't have to worry about that. Your log bases will always be greater than 0. Okay, they're always going to be greater than 0. Log base 0 I don't think works with anything. Because then it'd be 0 to the whatever. Well, you could have 0. Because then it'd just be 0. You could have fractional bases. You could have fractional bases because, remember, log base 1/2 of 2, log base 1/2 of 2 means 1/2 to the negative 1 is 2. Again, we're utilizing exponent rules. A negative exponent just means the fraction's unhappy. Flip it and da-da-da, it's happy. Unlike you all at this fine moment. Mental abuse to humans?
Exactly. Oh, I tweeted that.
I don't understand the Twitter.
No one does.
Oh, look at that. How does it make money? Seriously, how can that be a publicly traded company and make money when all it is just useless information, X amount of characters?
I think it's money from like ads.
Do you click on the ads?
No.
No. Then what's the point?
Sometimes I have some.
Their ads are annoying. Mostly advertising stuff like that.
I look at it when I see ads thrown on stuff that I don't want. I'm not going to buy their stuff. Go away. It's like watching live TV.
Even if it's something really cool,
Well, okay. It's like watching live TV.
like if lifestyle
Don't you
parts
hate
of
watching
YouTube.
live TV?
I don't know. SNL's pretty fun.
Well, that's fun. I get it. But, other times, if you're watching a show and you're like, I just want to fast forward the commercial. First world problems.
Catchy.
What's that?
You see commercials enough to get catchy.
No, I hate commercials.
You start
Only if they're
commercials,
funny, they're accessible.
Take a second and rewrite these 4 on your own, and we will check
Only
them.
times commercials are good is in the Super Bowl, and even then, all I want to do is watch them.
Anyway, so rewriting these things in exponential form, you get what?
3.
3 squared equals 9.
3 squared equals 9. Makes sense because it has to. Next one.
5 first. 5.
Next one.
X squared.
1/2 to the negative second equals 4.
And last but not least.
19 to the 0 equals 1.
See, logarithms are pretty sweet.
We're pretty good at that.
Not too terrible.
Until later.
That's true. They have to give you, see, and that's a good point. McCann brings up a good point. They give you the answer. So if it doesn't work, you done goofed. Go back and fix it. Oh no, I have to solve it for X now. I don't know what to do. I am afraid. So you have log base 9. I tried my best to type that in there. It didn't look all that great.
I
So
thought it was log G at first.
Yeah.
I was like, what?
So log base 9 of x equals 1/2. In order to solve this, you're going to want to rewrite that into exponential form. Exponential form says what? 9 to the 1/2 equals x. What's 9 to the 1/2? 3.
3.
Yeah. There's 3.
There you go. That's using the property to make it work. You use the x for the by rewriting in terms of exponential form to solve a lot of times. And it works out rather quickly. Especially for ones that you can do in your head. Okay? Now, what I want you to do here is I want you to start thinking about evaluating without using a calculator. Yes, you can press buttons on your calculator to figure these things out, and I'll show you when we need to know that the right way you might figure it out. But what I want you to do here is think about what is the value of log base b of y? You ask, what power of the base gives you y? So here, 3 to what power gives you 81? That's what you're thinking in terms of solving things. These would be the types of questions I would ask you via non-calculator, all right? Because there's stuff you're going to be able to figure out. So 3 to what power is 81? 4, good. Now, log base 5 of 0.04. What you'd want to do in something like this is to rewrite it as a fraction, okay? This, if you think, is log base 5 of 4 over 100. What is 4 over 100? Otherwise known as 1/25. So now, see how you're starting with an integer base, but your y value is a fraction. That meant your exponent has to be negative. That's how you make it unhappy. Okay? So 5 to what negative exponent creates a fraction of 1 over 25? Negative 2. Very good. Okay? Now I have a base that's a fraction, but my y value is an integer, which means my exponent needs to be, again, negative. That's how you do your switcheroo. That's how you're going to switch between integers and fractions with logarithms. Your exponents become negative. That way you can flip them. Does that make sense? So 1/2 to what power?
-3.
Excellent. X has to be -3. And then last but not least, log base 9 of 3. 9 to what power is 3?
1.5.
We just did that one enough. Mentally, not too bad, right? Well, we'll get there. I mean, to be honest with you, the first day or so of logarithms really isn't bad. What starts to get a little bit messy is when you have to expand and condense and then solve equations via that, because you can have factoring and all that kind of stuff thrown in there. Just to show you guys how you change your base in case you do get to the point where you have no idea where to go. On your calculators, I'll show you what the button is. It's a alpha window, or is it alpha something?
For tables? No, let's see.
It'll say
Alpha
log base
window.
on the screen.
Yeah, alpha window.
Is it alpha window?
It is alpha.
All right. So if you hit alpha window, one of the options on there is log base. One of your screens might look a little bit different, but it should still say log base on it. If you scroll to it or just hit number 5, it'll automatically throw the cursor for log base. That's where you enter any log base, whether you want to use log base 10, log base 4, whatever. So if you had to do log base 9 of 3, gives you 0.5, which means your exponent is 1/2. You know how to convert that to a fraction then?
No.
Math, enter, enter. Or use your brain. Okay. Now, if it is log base 10, you just hit the log button. It just implies that it is log base 10 at that point. Any other base, you have to do the alpha window. Alpha window, was it 5 for everybody?
Yeah.
It would be alpha window 5. Sounds like a call sign. This is alpha window 5 coming in for landing. Is the runway clear? Roger, Roger. Sorry. Thank you. Somebody got it. What are you laughing at? Like I was saying, this worksheet it's just got a lot of extra little notes and stuff in there. It's got a ton of extra examples. And what I want to do here with you guys real quick is on the second page, I want to take a minute or two and let's do the column on the right, okay? Let's do the column on the right and see how we do. So the first one was rewrite into exponential form. So log base 4 of x equals 3. To rewrite that into exponential form, what would it look like?
4 to the third. 4 to the third.
This would be 4 to the third equals x. It doesn't say solve, it just says rewrite. Okay. Log base 2 of y equals 5 means? Very good, very good. 2 to the 5th is 5. Or 2 to the 5th is y, excuse me. What's the next one? No, it's just throwing in variables. They're just throwing in variables. And I know because we say log base b is x. And remember, this is your b, this is your y, this is your x. That's
Alright.
it could be any letters.
Alright.
It just happen to use those. The next one is ones we haven't tried yet. Rewriting to log form. So what you want to remember is that log base b of y is x, so b to the x is y. You always want to keep in mind the equivalent forms going back and forth, okay? You got to keep in mind those equivalents. So if it's 3 to the 5th is y, what's my base? 3, okay?
We're all out of the way. I forgot to grab more. You're ready to do my question.
So your base is always going to be whatever has the exponent raised to. These bases, notice the log base 5 here is the 5 here. These bases will always be the same, okay? So here you're going to get log base 3 of what? Log base 3 of y equals 5. Very good. It's a matter of just getting accustomed to how these things are written. It's more common to go from logarithmic to exponential than it is exponential to logarithmic. Because when you're in exponential form, you can solve for x a lot quicker. That's all. I mean, eventually I'll show you guys how we can solve it via log form, but we'll worry about that next week. Next one, we have log base x of 32 is 5. And then what would the last one be?
Log 4 over 64 equals x.
There you go. Log base 4. Okay. The last one say solve. Okay. Excuse me. Solving. I'm going to put this on a clean one so I have a little bit more space. Oops, not allowed. So we have log base 2 of x over 2 is 5. Let's throw this back into exponential form because it's always easier to solve. What would that look like? Excellent. 2 to the 5th equals x over 2. So what do you do first?
2 by 2.
What's 2 to the 5th?
4
Times 2. And you get, dun, dun, dun. You get 64. You can check your work there because then it just says log base 2 of 64 over 2 would have to equal 5. And you can substitute that in your calculator and you'll get 5. Because it's log base 2 of 32. 2 to what power is 32? 2 to the 5th. And that's how these things work back and forth. Anything that, like especially today, a lot of this stuff should be calculatable by a non-calculator, if that makes any sense. You should be able to do it in your head.
Yeah.
I try to sound fancier than I really am, just to make myself feel good. You know,
Everyone does.
yeah. Log base 3 of y is 5. Is that it right now? Yeah. So that means 3 to the 5th is? Well, 3 to the 5th. Okay. I was going to say 3 to the 4th we know is 81. And we can do 81 times 3 in our heads, right? Yes.
I can do it on Latin.
Why isn't it
What?
It's okay. It's all right. And then the last one, we have log base 2 of 4x equals 5. Again, this means 2 to the 5th equals 4x. And what's x? Okay.
Couldn't you just take, since 4 is a root of 2, could you take that, subtract that from 5? Because like,
No, I see. There are properties that you can do.
and then that'd be 3 and you should.
Eventually, we can do this. Because this is log base 2 of 2 squared. So this becomes 2. I love logarithms. They're cool. They're really cool what you can do with them. It's just a lot of expanding condensing. It's just,
Confusing.
it's not confusing because I'm using power rules. These bases are the same. 2 and 2 are the same base, so the exponent just drops. It's one of the rules. And we'll get to that. We're not quite there yet. Okay. I don't think I want to get to inverses today. I think let's just stop here. So let me see what I have for you guys for homework then. Let me get my book out. All right. So let's do this for the first day here. So this is 8-4. It's on page 490. Let's do numbers 16 through 35. Okay. Now, what I'd like you guys to do here is the first 8 of them are just rewriting between logarithmic to exponential form. The last chunk of them, the last 12, are trying to simplify the logarithm. Try to do that without the calculator. Okay?
All right.
Seriously, I mean, it's log base 5 of 125. Means 5 to what power is 125? 3. Okay? Try to do that, okay? Try and do those. And we'll go from there. We'll build out of this tomorrow. We'll talk about inverses and maybe a little bit of graphing. I will say this again. Unfortunately, I will not be here during flex. Like I said, I got to go let a roofer person take care of the roof because it's fun. It's not on fire, so we don't need any water. We're not going to let it burn. Thank you. I'll get that stuck in your head now as well. As it's long, it's big, it's heavy, it's wood. Nothing. You just don't know the song. It's a great song, but it's not appropriate.